In this video, we're going to look at quadratic functions. Those are functions of the form y is equal to ax squared plus bx plus c. But before we do that, let's review what we know about functions. See, this is a second-degree polynomial. Let's review what we know about functions where this is a first-degree polynomial. You know a lot about these functions. Y is equal to mx plus b is what we've often called it. I'm going to use a instead of m. So here's an example. Y is equal to a half x plus 1. Here's an app that allows us to adjust a and b. See, there's the equation y is equal to 1 half x plus 1. As I adjust that a value, if it's negative, then I go down as I read from the left to the right. As the number gets larger, it gets steeper and steeper. That a value really calculates the slope. This b value really slides this y-intercept up and down the y-axis. Here we're looking at the rise, which suppose that we're going from a to b. The rise is how much we go up, and the run is how much we go over. Those are being calculated for us here. And then the slope, which is the rise divided by the run. We always run twice as far as we rise on this particular line. That's why the slope is 1 half. No matter where we do the measurement, the slope stays the same, but the rise and the run change, but their ratios stay the same. Okay, you know all of that about straight lines. So here's two important features to notice. That when we have y is equal to ax plus b, a, the coefficient on x, tells us the slope of the line, and b, the constant coefficient, tells us where the y-intercept is. In this video, we're going to investigate functions that are quadratic functions, and we want to be able to find a bunch of characteristics of those functions simply based on the coefficients a, b, and c. Let's pay just a little bit of attention to some vocabulary here. A second-degree polynomial in one variable is called a quadratic expression. When you take a quadratic expression and set it equal to 0, that's called a quadratic equation. In this video, we want to look at things where y, or the function, is equal to ax squared plus bx plus c. In other words, y is equal to a quadratic expression. These functions are called quadratic functions. So notice the distinction between quadratic expressions, quadratic equations, and quadratic functions. Now here are some mental images that are very helpful. Quadratic functions always graph to be parabolas. Parabolas look very much like a string hung between 2 points. That's an opening up parabola. Or they look like a water fountain. That's an opening down parabola. So those mental images are helpful. A technical note that you should be aware of is that hanging a string between 2 points really doesn't make exactly a parabola. It makes something called a catenary. This red line is the graph of the catenary, and the green line is the graph of a parabola. The thing that I want you to note here is that the mental imagery of that string hanging between 2 points is really very, very close to the shape of a parabola. Here I've graphed two parabolas, and I want you to notice some things about them. This is the parabola y is equal to 1/3 x squared minus 4/3 x plus 1. So there's the coefficients, 1/3 minus 4/3 and 1. It is an opening up parabola. Here are some of the vocabulary that we should be aware of. This point where the parabola crosses the y-axis is called the y-intercept. Here's an opening down parabola. It also has a y-intercept. These points where the parabola crosses the x-axis are called the x-intercepts, and this one also has 2 x-intercepts. Notice that a parabola could easily have no x-intercepts at all, because it could be an opening up parabola, say right here, that doesn't come down far enough to cross through the x-axis. Or it could come down and touch just exactly once. So the number of x-intercepts could be 0, 1, or 2, as you see in these two examples. The vertex is the low point in an opening up parabola. The vertex is the high point in an opening down parabola. There's a vertical symmetry line that goes through the vertex. That's called the line of symmetry. So those are some of the names that we'll be working with. In the next video, we'll look at ways to find, knowing the coefficients in a quadratic function, to find the x-intercept, the x-intercepts, the y-intercept, the axis of symmetry. Remember, that's that vertical line here that goes through the vertex. The vertex itself, if the parabola is opening up or if it's opening down, and be able to know something about the domain and the range. The domain on a parabola is all real numbers, but notice that the range is kind of interesting. In this parabola, it only takes on y values from the low value of the vertex on up. Here, the range are only those y values from the y value of the vertex on down. Okay, that's the idea. We'll look at those details in the next video.